Okay, now we will do section B, and we have 7 questions in this section. Okay, so for 6a, determine the nature of roots of the equation, of the quadratic equation, 5x squared plus 7x equals to 3. Okay, so first of all, what is nature of roots? So for quadratic equation, we know that we have 3 types of roots. Okay, quadratic equation, we have 3 types of roots. Quadratic equation, the highest degree is 2. So there are always 2 roots. They are either real, imaginary, or distinct or equal. Okay, so we can have 2 real and distinct roots, 2 real and equal roots. Okay, which means this one is sometimes we call it 1 real roots, but actually there are 2 roots. Okay, then the third one is 2 imaginary, and if the roots are imaginary, means it is the conjugate, the complex conjugate of each other, so they have to be distinct. Okay, distinct roots. Then how do we determine that? Okay, we will use the determinant b squared minus 4ac. So if b squared minus 4ac is greater than 0, that means it is 2 real and distinct roots. If b squared minus 4ac equals 0, means it is 2 real and equals roots. If it is b squared minus 4ac smaller than 0, that means it is 2 imaginary and distinct roots. Okay. Okay. Why? Okay. So the simple explanation for this is because your quadratic equation formula, you have x equals to negative b plus minus square root b squared minus 4ac over 2a, right? So if this is this is positive, okay, if this is positive, means the number here is a real number. And why do we have two distinct roots? Because we have x1, okay, x1 will be negative b plus square root b squared minus 4ac over 2a. And your x2 will be negative b minus square root b squared minus 4ac over 2a. This is why you have two distinct roots. But if the thing inside, if b squared minus 4ac is equal to 0, means the whole thing here is 0. So it doesn't matter if it is plus or minus. So for the second case here, x will just be negative b over 2a, right? Then for the third case, if b squared minus 4ac means the thing inside your square root is a negative. The negative, we know that the negative of the square root of a negative number is a complex number, and we have a I inside. That is why it is imaginary. And in my quadratic equation series, I think I have proved that if the roots are imaginary, then they are complex conjugate of each other. Okay, so this is what a little bit of revision. So now we will look at this question. We just need to determine the value of b squared minus 4ac. Okay, so the first thing we have to do is we arrange it in standard form. Okay, so the first thing we do, we're going to do it here. This is for 6a. Okay, 5x squared plus 7x minus 3 equals to 0. Then we take out a equals to 5, b equals to 7, and c equals to negative 3. Okay, and now we want to find b squared minus 4ac. We want to determine the value of b squared minus 4ac, which is 7 squared minus 4 times 5 times negative 3. Okay, so 7 squared is 49 minus 20, then the negative become positive. 20 times 3 is 60. Okay, so we have 109. 109 is greater than 0. Therefore, we say that, okay, so this is the answer. They have 2 real and distinct roots. Okay, so in Mandarin we call it 两个 okay, 两个 real is 实数10根 okay, real roots is 10根 then distinct is 相异 okay, 两个相异的10根 okay, put this 两个相异的10根 okay. Then for question number B, given that 2p and 3 are the roots of a quadratic equation, 3x squared minus 15x plus q equals to 0. Then find the value of p plus q. Again, this is another subtopic in your quadratic equation. Okay, so for this question, we need to use the concept of sum of roots and product of roots. Okay, so sum of roots, or we always write it as alpha plus beta, where alpha and beta are the roots of the quadratic equation, is equals to negative. Always remember we have a negative here, b over a, and product of roots, or alpha times beta, equals to c over a. Okay, and for this equation, your a equals to 3, b equals to negative 15, and c equals to q. Right? Then alpha plus beta means 2p plus 3 equals to negative 15 over 3. Negative become positive. 15 divided by 3 is 5. Then minus 3, 2p, okay. Then p is 2 divided by 2, which is 1. Right? Then for q, alpha beta, 2p times with 3 is equals to c is q over 3. And okay, so you have 6p equals to q over 3. Q should be 3 times 6 is 18p. And yeah, what is p? Okay, your p equals to 1 from here, isn't it? So equals to q should be equals to 18 times 1, which give you a q equals to 18. Right? So this is the answer for question number B. Okay, question number C. Oh, we have a quadratic equation, but don't worry. This quadratic equation is quite easy because you can, as you can see, you can directly factor out x, right? Then you can actually, when you factor out x, you will get a x cube. You will get highest degree is 3, which means you can use calculator. If you haven't learned factor by grouping or factor theorem, remainder theorem, or Newton-Raphson method, this is how you can do it. Okay. I think I will show you factor theorem and remainder theorem just for your knowledge. Okay. But just in case, okay. So this is how you solve it if you don't know any of them. Okay. Use calculator. But your calculator in your FX570, you can only go up to cubic equation. So you need to make it like this first. Okay. So x to the 4th minus 5x cubed minus 70x squared plus 21x equals to 0. Okay, so as I said just now, you can factor out your x. Okay, so you have x cubed minus 5x squared minus 70x plus 21 equals to 0. And just like your quadratic equation, if you have two brackets equals to 0, like if this is like bracket 1, bracket 1, bracket 2, then either 1 equals to 0 or 2 equals to 0. Right? This is actually your principle of zero products. For principle of zero products, it says that if a times b, okay, if a times b is equals to 0, then it's either a equals to 0 or b equals to 0, or both of them are equals to 0, because the product of 0 with any number is 0. Yeah, pretty simple concept. Okay, so same thing for this one. Means this one is equals to 0 or this one is equals to 0. So we can just solve this this cubic part just like we take it equals to 0, right? And yeah, we will write it in different brackets at the end. Yeah, I will not write this. Okay, so go to mod 5, then cubic equation is the third one. You just key in 1, negative 5, negative 17, 21. Okay, there you have 7, 1, and negative 3. Okay, so it's x minus 7, x minus 1, x plus 3. Okay, x minus 7, x plus 1, x minus 3 equals to 0. Am I right? Let's check that out. Okay. Sorry, this one should be negative 1 and plus 3. Sorry. Should be negative 1 and plus 3. Yeah, so with the principle of zero products, x equals to 0, or x minus 7 equals 0, or x minus 1 equals 0, or x plus 3 equals 0. So x equals to 0, x equals to 7, x equals to 1, or x equals to negative 3. Okay. I write it like this: x equals to negative 3, 0, 1, 7. Okay. This is the answer. So how do we do it with maybe we use factor theorem. Okay, I just show you just for your knowledge. You will learn this in form 6. Okay. Again, I write here minus 5x cubed minus 17x squared plus 21x equals to 0. Okay. So because we are solving this is actually a polynomial of degree 4. So polynomial if actually we cheat already lah. This one if we use calculator we know that we can factor into 1, 2, 3, 4, 4 factor, right? Okay, we can factor into 4 factor with no remainder. Okay, no remainder means okay. What is the meaning of factor and remainder? It's actually something related to your factor theorem and remainder theorem. Just like this. Okay, so if we divide 15 by 5, we will get a 3, right? So the remainder is 0. Okay, the remainder is 0, which means 5 is a factor. 5 is a factor of 15. Okay, so this is the meaning of this division here. But if we divide 16 by 5, okay, we will get a remainder. Okay, a remainder. So which means 5 is not a factor of 16. Okay? Okay, right? So same thing with algebra. If we divide the whole polynomial here by something, then we don't get any remainder. Meaning, okay. So this is actually we know that 15 divided by 5 is equal to 3. Okay, so it means there is this is a whole number. So 5 is a factor of 15. Okay, but for this one, 16 divided by 5, how do you write it? It's actually in mixed number. In mixed number, it's actually 3, 1 over 5, right? Right? Which means it is 3 plus 1 over 5. So if this polynomial here, let's say if x minus 8, okay, if we divide this on the whole thing by x minus 8, we'll get maybe a bracket, then we'll get plus something at the end. Okay, you can see this one is whole thing is one term. Okay, you're for one algebraic expression. Okay, the whole thing here is one term. So if you have two terms like this, means it is not a factor of that polynomial. Okay, so we'll just try to find the value. Actually, we can just try to find the first root or the first solution, or we call it first zero of this polynomial. Then we can find the rest. Right? So I will erase this part here. Okay, then how do you determine it? Okay, so we always try to get the factor in the form of ax plus b, okay, equals to 0. This is a linear factor, right? Okay, so we'll always try to find the factor. Okay, so for every polynomial, if we want to find the zeros of it, then we'll always try to find the linear factor of it. Okay, linear factor means it is ax plus b. Okay, and it is equals to, when it is equals to 0, linear factor equals to 0 because, right, you can see here the linear factor is equals to 0. Linear factor equals to 0, right? So if ax plus b is equals to 0, means x should be negative b over a. We just need to find the possible value of negative b over a. Make sense? All right, yeah. So I write here possible. Or I directly write negative b over a. Okay. This negative b over a is different from your quadratic equation one, because this one is for the polynomial. Okay, then how do we determine the value of b over a? Yeah, so actually we are considering the factor of the highest power and the x with the highest degree and the x with lower degree. And actually in this polynomial here, the x with lowest degree should be 0. Okay, 0 x to the 0. Okay, so what is the factor of 0? Obviously is 0, right? Then what is the factor for this 1? Is 1. So we already have two possible x value, okay, and we can just use it to find the rest. So obviously, okay, from here we know that, okay, the factor of this polynomial here are x minus 0, okay, x minus 0, x plus 0, okay, x plus 0, x minus 0, doesn't matter, and x minus 1 and something else, right? Then multiply with something else that will give us back this one. So how do we find it? I think we can use something from here. Yeah, when we factor out x, we will actually get this part, right? Highlight this part. Okay. So before that, let me just write like this. Okay, so it is x cubed minus 5x squared minus 17x plus 21 equals to 0. And again, we know that it is x minus 1 is a factor. Okay, we know that x minus 1 is a factor. So just like your long division, you just divide this part. You just divide this cubic part by x minus 1, right? So this is the long division. This is what you call a long division. I will show it to you. Okay. So x cubed minus 5x squared minus 17x. 17, yeah. Minus 17x plus 21. Then you divide by x minus 1. Okay. Okay. So you ask yourself, how do you get x cubed with x minus 1? You need to multiply it with something else, right? So let's use the green color. So x minus 1, if we multiply it with x squared, then you get the x cubed minus x squared. Okay? Then you don't care about this one first, you focus on this one. Okay? So you just write x cubed here. So you have a x squared, sorry, this one this is x squared, this is x cubed minus x squared. Okay? Then remember your primary school math. How do you continue with this? Yeah, you minus, right? You minus this to this. Okay, so -5 minus x, you get a -5 plus x, which is -4x squared. Then you bring down this term, 17x. So far so good, right? Then for the next one, again, how do you get x squared? How do you get -4x squared with this one? You need to multiply it with -4x. So you have a -4x squared. Negative become positive 4x. Right? So we have a -4x here. -4x squared plus 4x. Okay. Then again, I think I'll use the next color, right? It is a minus, right? Why is it so big? It is a minus. -4, -4 is 0. -17 minus 4, you have a negative 21x. Okay, so this one you say kacang you just multiply with -21. You get a -21x plus 21. Okay, then what should we put now? -21. -21x plus 21. Yeah, you see, the remainder is 0. So we have proved that x minus 1 is equals to is a factor of this polynomial. Okay. Then what should we do next? Still remember the example from just now? You 15, you divide by 5, 3, 15, okay, then 0, which means 15 divided by 5 is 3. So 15 equals to 5 times 3. Okay, so you just have to multiply. If you multiply this, okay, perhaps maybe I should use highlighter. Okay, if you multiply this with this, then you will get this, right? So the next thing we do is, okay, we take out this x minus 1. When we take out this x minus 1, what we left is x squared minus 4x minus 21 equals to 0. And this is already a quadratic equation, and you can solve it. just like a normal way. Or if you want to continue to use the log division, also can. But since we already know how to factor quadratic equation, so we just directly factor it. Okay, so green color, x times x. Do some also thin here. Okay, x times x will give you x squared. 3 times 7 give you 21, and difference between 7 and 3 is 4, right? And now we want a negative 4, so means the negative belongs to the greater number. When you cross multiply, you have a 3x, negative 7x, you have a negative 4x. So at the end, you have x minus 1, x plus 3, x minus 7 equals to 0. So x equals to 0, x equals to 1, x equals to 1, sorry, this one is 1, x equals to negative 3, x equals to 7. They arrange it, x equals to negative 3, 0, 1, 7. Is it the answer? Yeah, negative 3, 0, 1, 7. Okay, so this is how you solve a high degree polynomial, and this is actually a very simple examples where you don't have any remainder. Okay, yeah. So I hope this is a good exposure for you, and I hope you learned something. This is very useful. This factor theorem and remainder theorem is very useful. And if you learn differentiation, right, actually you don't have to do all of this. You actually have another method called Newton-Raphson method. Okay, Newton-Raphson method. You just need to get any one factor of that polynomial, and you can use its derivative to find the next factor. Okay, but yeah, you'll learn it later, not later, in the future. Right? So this is for question number 6. I'm not sure if we can finish this by today, but I think we have to go faster from now. Right? Okay, 7-8. Find the sum of first 16 terms of the geometric series, negative 2 plus 6, blah, 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 blah. Okay, so first thing, this is the geometric series. Means they have the same common ratio. And what do we want? We want sum of first 16 terms, which is S16. And we can just use the formula, right? But before that, your first term, what is your first term? Is negative 2. And what is your common ratio? Common ratio is 6 divided by negative 2, which is negative 3. Or you can check it again. Negative 18 divided by 6, which is negative 3. Okay, and now we just sub in the formula. Okay, okay, I will directly sub in. So it should be a negative 2 times 1 minus negative 3 raised to the 16. Okay, then divided by 1 minus 3. Okay, I think I will just quickly use the calculator. Sorry. Alright, so it's negative 2, 1 minus negative 3 raised to the 16, then 1 minus 3. So it is 215,233,60. Okay, 215,233,60. Okay, make sure you don't copy wrongly from the calculator. Okay, question number 7 is a matrix question. It's your form 5 math. Okay, so we want to find the inverse matrix of it. Okay, find the inverse matrix of it. Then we use the inverse matrix to solve this system of equation, right? So A, okay, so this is for question B, alright, equals to, not equals to, sorry, it should be A inverse is 1 over, okay, so it should be a 3 times 3 minus 5 times 4, minus 5 times 4, then this and 3 and 3 you switch, so it's still 3 and 3, then you change the sign for this one, is a 5 and a negative 4, right? So it's a 1 over 9 plus 20, okay, 3, 5, negative 4, 3, which is 1 over 29, 3, 5, negative 4, 3, right? And now we will solve this system of equation. Alright, so it is 3, negative 5, 4, 3, x, y equals to 14. So x, y should be the inverse matrix. You multiply both sides by inverse matrix so that you will get the identity matrix for this one. Okay, so it's 129, 3, 5, negative 4, 3, 14, 9, 9. Okay, can you follow? Yes, sir. Right. So I think we'll leave this one for 29 later. Let's do this part first. It's 3 times 14 plus 5 times 9, and negative 4 times 14 plus 3 times 9. So it's 129. This is okay, just use calculator so that we don't make any careless mistake. 3 times 14 plus 5 times 9 should be equals to 87. Yeah, 87. Then for this one is negative 4 times 14. Negative 4 times 14 is 56. Then plus with 3 times 9 is 7. So should be 29. Negative 29. Okay, negative 29. Then this is obvious. Your x, y, you just multiply this. 87 divide by 29. Okay, 87 divided by 29. We have do you have negative? No, yeah. So it's 3 and negative 1. Okay, 3, negative 1. So x equals to 3, y equals to negative 1. Okay. Okay. Yeah? Then we go for part C. It's in this question, 2x minus 1 plus 3x minus 1 equals to 2. Then we correct to 4 decimal place, means the answer will be very ugly. Yeah? But before so what should we do? So the first thing we have to do is we try to get rid of these 2, right? So it means we multiply with the whole thing here. Will multiply with 3 to the negative 1, which is 1 over 3. So I'll write like this: 2x over 3 plus 3x over 3 equals to 2. And what can we do here? We can multiply both sides by 3, so that this 3 can all cancel, and we have 3 2x plus 3x equals to 6. Okay, and we'll move this to the other side. 3 2x plus 3x minus 6 equals to 0. Then what should we do next? Just look at it carefully. And perhaps maybe I write like this. Okay, 3x. So sorry about this. Square plus 3x minus 6 equals 0. Can you see it? This is actually a quadratic equation, isn't it? Okay, we just let u equals to 3x. So we have a u square plus u minus 6 equals to 0. Right? And this is actually u times u, then 3, 2, negative here. 3u, negative 2u, we have a u in the middle. So u plus 3, u minus 2 equals 0, u equals to negative 3, u equals to 2. And remember, yeah, you have to, just now you let u equals to 3x. So 3 to the x power, negative 3, then 3x equals to 2. And what should you do next? Just convert it to log. Okay, so log base negative. Okay, so log base 3 negative 3 equals to x, and log base 3 2 equals to 0. Okay, and we know that the argument of a log cannot be negative, so there is no answer for this. So we just reject this answer. Then we just focus on this one. Okay, log base 3 of 2. This one should be 0.6 something, okay, if not mistaken. Okay, 3, 2. And actually, in one of my video, I actually show how to estimate. How to estimate the value of logarithm. It's quite interesting. Okay, yeah. So x is wait, where's your x? This is your x. Sorry, this is your x, and this is your x. So your x is 0.631. 0.631. Okay, so far so good for question number 7. Right? Then we go for question number 8. Okay, it's a triangle question, and we have circular measure, and we have, I think this is solution of triangle. Anyway, okay, proof identity. Cotangent theta plus tangent theta equals to secant theta cosecant theta. So, yeah. So if you see the right hand side, okay, we will start from left hand side. If you see the right hand side is like secant, cosecant, sine or cos, and on left hand side you only have cotangent, tangent, you just convert all the cotangent and tangent back to sine and cos. So that later is easier for you. So add A and left hand side equals to cotangent theta plus tangent theta, which is cos theta over sine theta plus sine theta over cos theta, right? They just combine these two fractions together. This should be a cos. You multiply this one by cos and cos, okay? Cos and cos. Then multiply this one by sine and sine, okay? And I think you can see it already. This is a cos square theta plus sine square theta over sine theta cos theta. Okay, so this is actually your basic identity. Sine square theta plus cos square theta is equals to 1 over sine theta cos theta, here. And it is 1 over sine theta over 1 times 1 over cos theta, which is cosecant theta secant theta, which is secant theta cosecant theta, okay, equals to right hand side. Proven. Okay, it's very easy. Okay, at B. CAB is a sector with center C. Okay, center C. AXY is another sector with AXY. This one is another sector with center A. CM is CM. CM, where is your N? I think it's a typo. There's no M. I think it's given that CB is equals to 10. AY is 4. And XAY is 1 radian. Then find the ACB, okay, ACB in radian, and the perimeter of shaded region, right? So first thing we need to find this angle here. And we already have the S here, we already have your R here, so we can just use S equals to R theta. So S, where's your S? 7 equals to R, this is your R. This is the R that we want to find. R times, this is the theta. Sorry. This is the theta. Your R is 10. 10 theta. This is theta. So theta equals to 7 over 10 radian, which is 0.7 radian. Okay, 0.7 radian. Then now we want to find the perimeter of shaded region. Okay, so we just need to find this one is 7, means this one is 3. 7 minus 4 is 3. Okay. This is a 3. Okay, this one already got, huh? This is a 3. This is a 10. This is a 7. We already know. Okay, so now we just need to find AX. Okay, we just need AX and XY. Okay, and XY. Sorry, AX we already got. This one, this and this actually equals, so this is 4. We just need to find XY. And XY is another. Okay, XY is another R theta. R is 4 times theta is 1, so it's 4. So the perimeter should be, okay, 1 by 1, the whole, okay, the area of the perimeter of shaded region. Okay, we start from here. This 7 minus 4 is, sorry, this one should be 10 minus 4, so it's 6. Sorry. See, careless mistake can be made anyway. So it's a 6 plus, okay, perimeter is 6 plus this side is 10 plus this R is 7 plus, okay, this is 7, this is 4 plus this one is 4. Okay, then just press calculator. Okay. 16 and 9. 6 plus 10 plus 6 plus 10 plus 7, then plus 8. So it should be 31. Okay, equals to 31 centimeter. Okay. And question number C. Solution of triangle. In triangle PQR is an angle. Given the area is 27 cm cube, then PQR equals to, this one is equals to 18 cm. Find triangle AQR, angle PQR, and the length from R to PQ. So for this type of question, we always try to draw out the triangle first, right? So we have a triangle PQR. Your angle Q is an acute angle. Okay, so this one, let it be Q first, then PQR, right? Then the area is 27, PQ, okay, PQ is 14, QR is 18. Then we want to find PQR, this angle here. So, how should we do it? We know that, okay, so the area is half AB sine C, so equals to half, and the area is given already, is 27, equals to half A is 14, 18, then sine Q. Okay, so sine Q, okay, just directly this one, 27 divided by half times 14, 18. 27 divided by 1/2 times 14 times 18. Okay, it's a 3/14. Okay, it's 3/14 sine Q. So Q should be the arc sine of it. Okay, Q should be arc sine of 3/14. Okay, then you just press your calculator. Arc sine of it 3/14 equals to 12.37. Okay? 12.37 in degrees. If your calculator is in radian, I think should be fine if you leave the answer in radian. Okay, and now we're going to find the length from R to PQ. Never mind. Okay, the height. So actually my triangle is not so nice. Okay, so we want to find this height. So if it is like the height of it means okay, should we use any formula? Okay, I think I got it now. This side we should if when we draw the triangle, it's better to draw it nicer. Okay, so let's say I draw it again. Okay, Q here, let's say R, then P. Okay, then PQR is 18, 14. Let's say this is a height. Do you notice that the area of this triangle is equal to half times base times height, right? And we already have the area of this triangle, which is 27. It's given in the question. Yeah, is 27. So we can just use like this. 27 equals to half times 14 times h. So this is 7h. 7 equals to 7h. So h equals to 27 over 7. Okay, and I think that's the answer for part 2. Okay, so that's all for question number 8. Clear? Good, huh? Okay, so now we'll take a break.